Welcome back. For any energy system, it is important that the power generation and power demand are in balance at all times. In this lecture, we will focus on the demand side by looking at the different kind of loads. An electric load is a component at the output side of a PV system or part of an electricity circuit that consumes electrical power. The learning objective of this video lecture is to recognize different types of loads in terms of the output form of its energy, like light, heat, or mechanical energy, or as the sector the loads are being used for. Electricity can be converted into many other energy forms. For example, it can be transformed into energy forms that can be directly used by consumers, like light, heat, and mechanical energy. Active power is the usable power. It's the portion of power that produces a net transfer of energy in one direction every cycle. Load is able to use this power to do work. In DC, the power supplied by the load is the same power that is transferred towards the load when no losses are assumed. In AC, this is just a portion of the total power per cycle. In contrast, reactive power is the portion of power that returns to the source in each cycle and therefore cannot be used by the load to do work. Reactive power is considered in AC. In this course, we will not in great detail discuss reactive power, but it's important to mention that the efficiency of the system increases as the reactive power flow decreases. A load curve or load profile shows the variation in the electrical load, also called demand, in a time frame, for example, a day. This information is relevant for generation companies and system operators, as the generation output of the controllable generation units will depend on the forecasters and actual demand. In this example of the Dutch electricity network, it is shown that during the night the load is lower than during the morning, afternoon, and evening. A power balance between generation and demand should be kept at all times to keep the system stable. Let's have a look at some important types of loads. One of the main loads is lighting. Major changes have occurred during the last decades in order to make lamps more efficient. The incandescent lamp has a relatively low efficiency and has been replaced by the fluorescent lamps and later on by the LED lights during the past years. LED stands for light emitting diodes. The incandescent lamp is the oldest type of electric lamp. It consists of a thin filament that conducts electricity. When switched on, the current heats the thin filament and radiates light. To prevent oxidation, the filament is inside a glass bulb filled with an inert gas. This load is a purely resistive load, therefore it only consumes active power. The fluorescent lamp is based on emitted electrons that collide with mercury ions, resulting in ultraviolet radiation. A ballast, which is an inductor, is required to limit the current flow. Fluorescent lamps consume considerable amounts of reactive power as opposed to the incandescent lamps, which only consume active power. The light emitting diode, the LED, is a semiconductor that emits light when current passes through it. The LED lamps have a low energy consumption and long lifetime. LED lamps can have effect on the power quality as well, as they produce distortions in the AC waveform. Now that we have covered some important light loads, let's have a look at the heat loads. In a heat load, electricity is mostly converted directly into heat by a resistor. Some examples are a boiler, the water cooker, the electric stove, and the aluminium and steel furnaces. When the load is fully resisted, it does not consume reactive power. A second approach is induction cooker that transfers electrical energy by induction from a coal or wire into a metal pot based on ferromagnetic materials like steel or iron. The coil is mounted under the cooking surface and a high frequency 24 kHz alternating current is passed through it. The electromagnetic field induces large eddy currents in the pot that is close to the cooking surface. For high efficiencies, there should be as little electrical resistance in the coil and as much as possible in the pan so that most of the heat is developed in the pan. The mechanical loads have an important participation in the demand curve as well. The conversion from electrical energy to mechanical energy is done by motors. The first motors developed were operating with a direct current. Some examples of direct current motors are electric trains and hard disk drives in computer. Nowadays, there are many motors operating in alternating current. Motors are inductive components and as a consequence they consume reactive power. Loads can be classified per sector or by consumption into residential, commercial and industrial, and transport. Residential loads are connected to the distribution system. The common voltage ratings of distribution systems are 12 kilovolts, 11 kilovolts, 10 kilovolts or 7.2 kilovolts. Distribution transformers are used to bring power down to lower levels, for example from 10 kilovolts to 400 volts. Residential loads are in general single-phase loads. In the figure you can see that the distribution system has three phases denoted as A, B and C. In order to keep the three-phase distribution system as balanced as possible, houses are connected to the different phases. Please notice, for example, that the house on the top to the left is connected between phase A and the neutral, whereas the house on the top to the right is connected to phase B and the neutral. Commercial and industrial loads are generally connected at the distribution level, so around 10 to 72.5 kilovolts, or at the subtransmission level, which is 110 to 150 kilovolts. In many cases, the public utility brings underground cables or overhead lines to the premises of the company. The company generally owns the medium and low voltage transformers required to bring the levels to the ones required by the loads. In the coming years, larger loads are going to be connected at the distribution level. For example, electric vehicles. The decarbonization of the passenger cars by the introduction of electric cars means that the energy carrier electricity has to replace the role of fossil fuels that are currently used to power the vehicles. Batteries of different sizes, like home batteries, car batteries, or large-scale battery systems will also play a bigger role in the distribution systems of the future. In this video lecture, you have been introduced to the various types of loads. Electrical loads can be categorized in terms of the final functionality of energy output as light, heat, or mechanical energy. In addition, loads can be categorized in which sector they are being used, like residential, commercial, and industry, or in the transport sector. The loads are part of a larger energy system. In the next video lecture, we zoom out and we'll introduce you to the electricity network. So, see you in the next video.